for today, what I want to do is to explain the first homework. I need you to start working. In particular, I want to start working with programming, and I would like you to do some programming review of the things that we have been reviewing here from a mathematical theoretical perspective. I want to give you some source code, the one that we reviewed before. Hopefully you already have access to that. You play with that. If not, the homework is exactly me asking you to do that. Take a look to the source code, go down to the source code, and do your best to understand, if not everything, at least key parts that I am going to point out today. Previous lecture, I mentioned the homework. I prefer, or I stop to say, I am going to ask you a specific question because I need you to put particular attention in particular things that I would like you to take a look and understand. Either you understand from a point of view of, I know what is happening because this is programming and they are used arrays, or if you have a mathematical background to connect that with what we talk here about derivatives and calculus and so on, the better, but at least the basic understanding. So my first assignment for you is going to be to review some source code, to answer some questions that I am going to put here to be sure that we agree of what I am asking. Moreover, if you already review my program, you notice that there are some lines that are suspicious. Yeah, they are there because they should be there. Some of my questions are going to be, hey, did you notice these lines? Why they are in this way? Why they are different from something? They are better, they are worse. Do you understand what is happening here? What is the difference compared with something else that we review? I am going to ask you that. Moreover, I am going to ask you to modify the program to do something else. A small modification, small things. But again, my goal is that by asking you to modify the program, I am forcing you to play with the source code, to understand the source code, and at least print partial results or debug and see what is happening inside of the variable. My homework is basically that, forcing you to review the internal thing of this software. Later, you're going to have the opportunity to do something more interesting. Good? Okay, so just to be sure that the homework is clear, I am going to check the following. We are working with this neural net is just one layer. And something that I am going to ask you to follow is using these names. We're going to be playing with this input 1, input 2, W0, 1, 2, 3, 4, 5, 6, 7, 8, output 1, 2, 3, 4. During your homework, during my questions, I am going to be referring to these names, and I just want to be sure, remember the picture. If I ask you about the output 2, is the output of this node here. It's not like I am trying to ask you to create another output to the full network, right? I am asking about these names, and I put those names just to be sure that we can communicate and we know what is the line that I am talking about. Clear. Moreover, in some point, you will notice that in the source code that I give you, you have these crazy things like array in the position 1 is equal to another array in the position 3 plus another array in the position blah, blah, blah. In some point, I am going to ask you, this is the source code. These arrays, blah, blah, blah. Can you translate that to these variables? So if in my program, I am talking about array position 3, what is that? Array position 3 is talking about the output 2, the output 1, the W2, the W3. I want you to map. Good? So this picture, something that you could want to have with you while doing your homework. Now, the source code that I give you, the source code that I am asking you to use for the homework is available there, GitHub. If you already have it, yeah, great. If not, it's there. Follow the link. It's one file, and it's 124 lines. 124 lines. I am asking you to do a paper that explains or answer some questions about that program. I think it's not a challenge for you. I mean, 100 lines. You have everything. Everything the original version that I showed you in the previous class. That is what is there. That is not exactly the correct one, it is the original. But playing with that source code, in my previous slides, you have the explanation for everything. But the step number one that I will ask you to do, just to be sure that you get the correct file, and then you can modify and other things, is get the file and run the file. Makes sense, right? Just to be sure that everything is going to work. You do not need any library or any configuration. It should just work in your computer. I mean, if you have any way to compile Java, even in the console, it's going to work. Moreover, you can run. And if you press run, your result is going to be something like this console here. I do not know if you remember, but the explanation that I gave in the previous lecture is that this program is doing something 10,000 times. Well, what I did in my program is to print a number inside of that for loop that is running 10,000 times. So you're going to notice this number. That is going to be from 0 to 99999. Why 10,000? Why not? You want 100,000, you can modify. You want 20,000, you can put it. I just put this 999 just because. Just because you need to do it several times. Remember, you are training the net. You need to insist in the correct results many times. 10,000 is good enough for this problem. Remember, it's only 4 nodes. So no particular reason for that number, is just the number that I am running. You can increase or decrease. The thing that is going to control or should control this number, because one of the things that I am going to do is ask you to change your data set. And when you change the data set, maybe you can need more or less for this. Remember? What you are looking is for the error, not for the number of times that you run it. The second thing that I am printing right now in the software that I give you is this decimal number. That decimal number, the error. Well, this error function. If you run it, you start in something like 0.4. The numbers are going to change every time that you run it, just because the calculations and the inputs. But for my inputs, for what I have right now, for the text that I give you, if you run it, these are the numbers more or less. You start with 0.4. Professor, you tell me that these numbers can change. So if I run the second time, that 0.4 could be 0.5. And if I run another time, it could be 0.6 and so on. Can you explain me why? Okay. The starting point, and in particular, we're using random numbers for some things, remember? Those random numbers in the W's and the bias are going to make your numbers to change. So it's not that your computer don't work or the program will not work. It's working. The first numbers can change. But it's going to be about that 0.5 error. 0.5 is a good or a bad error? Very bad. 50% error. But you're looking for the error. And this is just something for you to be aware of the number that you are looking. It's not a rule, but usually when you report errors, what you're looking is for something that is below 0.05. I prefer the 0.04. It's fine. It's just a number. Remember the metrics with the software. Complexity, 10 lines or more, 10 methods or more. It's just numbers to give you an idea what is good and what is bad, not a hard number to follow. The errors that you're looking for, something that could work, is at least 0.05. You will notice with the 10,000 things that I give you, at least the problem that is there solved, 0.01. So it's not so bad. It is not good, it's just not so bad. Good? What is going to happen? I am going to ask you to change your inputs. If you change your inputs or your outputs or both, it will change, increase or decrease. Again,
a good solution, a solution to my question is going to be that even changing the inputs or the outputs, the problem, you still get something lower than 0.05, hopefully 0.01 or lower, but at least 0.05. Good? Perfect. Great. So things that you did, things that I explained before. The first thing that is going to run is the constructor. We reviewed this in detail previously. Any question I can follow, but if you understand that after running this code, this is what you have in the memory, we are good to go. I have some variables, and the values are 0.7, 2, 1, 3, and 3 arrays. Do you remember what are those? Do you remember that we have those names of variables, and basically the number of input, the number of output, and the number of hidden values? 2, 1, 3. And the 0.7, our learning rate, the constant that is going to multiply. They are there as globals. The arrays, values, weights, bias, size, the values, 6. Why 6? Because I put together the outputs and the inputs. Why? To facilitate the programming only, right? You need to remember this because you're going to be playing in the source code, particularly in the back propagation, and you're going to be using these array values. And the tricky part is I want you to have in your mind that every single time that you are using array values, the first index, 0 or 1, you are working with the values that are inputs. But when you move after the input nodes, in particular, you're going to notice this source code that is like, hey, array values, square brackets, you're going to notice this. Why are you using array values that are supposed to be the outputs, something that is an index, but you're adding this? Oh, remember, because this is the number 2, so you are adding 2, and when you are 2, basically you start with the outputs, ignoring the inputs. In some places you do that, in another places you're going to start from here. Clear. Again, if you know what I am talking about, you can move forward with the homework. Array weights. These are the letters that correspond to each of these cells. Hopefully you agree. W0 is the element 0 in this array. W8 in the picture is the last one in that array. If in some point I ask you to translate some crazy equation like this through the letters there, you can imagine array values, input nodes, layer, this thing. That one I am talking about output 0, the array in the position 2, or W, whatever. I am giving you this slide, like the equivalence of the name in the program with the name in the variable for the picture. Good. Okay. The bias. There is an array for the bias, and it's 6, just like the array of the values, that is 6. One question that I have for you in your homework. Do we need 6 bias? How many bias do we need? And why do we have an array with 6? I agree with you, we need 4. In fact, there are 4 that are being used. Still, we create an array of 6. Are you telling me that you only need memory for, yeah?
Match it with the input, it will make us easier.
Yes. I want you to observe that we're using more memory just to make the source code easy, not to follow because it's not exactly easy for the humans, but smaller. And I want you to notice, to follow one question that I ask you is exactly the one that I ask you right now, and you give me the answer. So you need to document exactly what you tell me in your document that you're going to submit. But please, before doing that, keep an eye of this variable. Search for the variable and notice which of these are being used. And you're going to notice the use of the memory. Objects are a problem. And if you need to balance memory and performance, performance is more important. Yeah, you're concerned about the memory in particular cases, but in this case, the memory is not going to be an issue. There are going to be a very small number of nodes. The performance is better. The generalization is better. We're doing something there that is wrong with the memory for the bias, but it helps. I want you to notice how it's helping. Good? Easy. The big part in this system that is doing something, and I need you to put particular attention at what is happening. We already described this, but I just want to be sure for some questions that I received. Do we understand here in the main that you have these three loops, one inside of the other? And in particular, we agreed that the external loop is the one running 10,000 times, 0 to 99999. But then we understand that inside of that one, we have this loop that is going to run 4 times each. And 4 times because there are 4 inputs in our array of inputs, 0, 0, 1, 1, 0, 1, 1, 0. That for loop is running 4 times because those are the combinations that I am giving as an input. Moreover, that inside of that one, I have this for loop that is not really a for loop because for the particular scenario that we have in the picture, it's going to run only 1 time. So that one, you can almost delete it. But why do we have that one there? The output of the neural net, right? This one is 1, only 1 output. But if you put 2 outputs, this for loop run 2 times, or 3 times, or 4 times. So what you have right now, what you are reviewing is this 10,000 for 1. 1 output, 4 different combinations in the table of inputs. And repeat that 10,000 times for training. Clear. Moreover, I put these colors, hopefully. Did you notice that backpropagation is going to run for every single time that you run an input? Backpropagation is for every single row the input. Now, the calculation of the error, yes, you calculate the error when you finish with everything for every time that is 1 from 0 to 999, but there is a partial error here that is being calculated that at the end is added. Remember that this guy is an addition of all the partial errors. Just follow that. Now, what I am explaining to you, what I am pointing you to review and understand and print things or the book is that what is happening is this process. 10,000 times you are going to do 4 things. With 0, 0, forward propagation, calculate the error, back propagation. With 0, 1, forward propagation, calculate the error, back propagation. With 1, 0, the same. With 1, 1, the same. And when you finish with these 4, you calculate the full error for that first iteration. And again, and again, and again. Remember, 10,000 times, 4 things, and 1 calculation of output. So it's 4 things, 10,000 times. This is the process. This is the moment in which you put the addition, that you're calculating errors. And you remember that this backward propagation is calculate the W's. So I want you to notice that when you calculate the W's, or you modify the W's for the input 0, 0, when you are going to do the next one, 01 is with new W's, not with the same that you used before for the 00. And when you do W's for the 10, is with the new version of the W's that have been improved 2 times. And the next one 3 times. And the next one, and so on. It's not one W with all the inputs. Because in this case, you know that there are only 4 inputs. But in the real scenario, in a different scenario, the inputs are just different, period. Clear? Easy. Good. So, next. Back propagation, forward propagation. Obviously, forward propagation, very simple. 3 blocks. We explained the 3 blocks before. I want you to notice, what do you do to calculate a node that is in the middle? And what do you do to calculate a node that is at the end? In particular, I want to be sure that you can map that source code with this. Do you remember the array, right? The array of values or the array of weights? Right now, for the forward propagation, the array that you're going to be using is the array of values, not the others, because you're calculating values, right? The array of values, in particular, hopefully you agree with me, and hopefully you can search in the source code to prove me correct or not, that what you are going to do is you are going to calculate the value for output 0, arrays values position 2, arrays values position 3, and array values position 4. So the 3 letters H that I put there in blue, and that the values that are going to be put there in those 3 positions correspond to output 0, 1, and 2, output 0, 1, and 2. They are going to be calculated with the equation in blue. Zip mode, del bias, plus the multiplication of the input 1 and a W, and the addition with the input 2 and the W. That is the correct equation, right? That is going to be the equation with the letters. Can you prove that that is the real equation that is in the instructions in the previous lectures or in the source code? Because in some point, according with this, you are going to have a sig mode of array values in 0 times array weight in 0. That is going to be the multiplication in the code, right? It is true. Yes, it is, but I want you to notice. I promise that that is the equation. Finally, in the same method, you are going to have in some point array values in the last position, output 3, equal to that equation in yellow. It's the same one, almost. Here I am using outputs, there I use inputs. It's the same array, different index. And you are going to notice what we do to adjust the index. But that should be the equation. Because if that equations are true, the yellow and the blue, everything that I explained to you, the previous week, is true. If not, we have a problem, right? The source code do not match with the theory. Okay, I promise it's going to be true, but I need you to review it. Clear. This is the easy one, the complex one. You know, the back. Important parts in the back. That one, and the last 2. What is happening? I give you comments. Calculate the bias, calculate the weights. In the previous one, calculate the derivatives. In this point, I cannot assume that you know how to do derivatives, but I want to know if you know it. In this point, I am going to ask you in your homework, the last question. I am going to show you the question later. I am going to ask you to, number 1, explain to me what is happening here from a computational way. I want you to explain me this equation here, what it is in terms of the theory that we reviewed before. So you can just limit your explanation to addressing my slides before. So to show me that you were here and understand what happened. Scenario number 1. But I put a note in the question with an extra Are you familiar with calculus? Are you familiar with derivatives? Can you go further and explain to me the derivative? Because if I have here 1 or 2 people that have this background with derivatives, I just want you to prove that whatever I mentioned before, either because you know it or because you want to research and go, that all these things that I described with derivatives is true. I promise it is, but it could be good that some of you prove that it is, or maybe not, I don't know. Extra question at the end, I am asking you for the mathematical part, but for everyone, I am asking for the computational part. This is the core for the paper that I am asking you to write. This is the core that I am asking you to explain to me, the backbone. Not because we're particularly interested in neural networks, just because if you can explain to me the back propagation here, then the next time that I mention that any machine learning algorithm is used linear algebra inside of the computer, then we can move forward. You can believe me. That is my goal with the first homework. Makes sense? Okay, I am not going to explain this now. I didn't provide to you a full detail of what is happening here. Is the core of my question. Now, what I am asking you to do as a homework is a paper. I am asking you to explain to me things, and I am going to give you questions that are going to drive that paper. Why I am asking you for a paper? 2 things. I want you to put your ideas on a paper that is going to help you to organize things, sharing with someone else in a piece of paper the answer to my questions, the ideas that you have when you read the source code. Hopefully that helps. So a paper, how long? As long as you need it. I am not going to ask you for amount of paper, for number of words or lines. But I think you can figure out that my questions are not going to be easy to answer in 1 page. I mean, I am going to be very surprised, and believe me, I am going to read your paper if you explain everything, my questions in 1 page. It's like, wow. Even is 100% correct and wonderful, or is missing things. So no limit of the pages or the sentences. Do not ask me that. My question is going to be whatever you need. My answer is going to be whatever you need. Second, maybe the most important, I am asking you to put these answers in a paper. I want you to do that. I want to be sure that you do this analysis. Moreover, as a paper, you're going to upload your paper to Canvas. It's going to be reviewed for academic integrity. Please use your own words. Copy paste from the web is going to be checked as copy. Copy paste from a partner, a classmate, is going to be checked as possibility of academic integrity issue. The tool gives you this percentage of similarities. If your paper is similar, 10%, 20%, something like that, no problem. I mean, we all can cite other sources. But please, 100, 90, 80, bigger the number, higher your problems. I do not want to report anyone to academic integrity in the homework 1. It had happened before, hopefully not this time, right? Anyway, please, you're going to read a paper. It's going to be reviewed for plagiarism. Avoid that. Use your own words and help me to answer the following questions. 1, a block of 3 questions. It could be possible to reuse the code that I am giving to you, and instead of XOR, because that is what is solving the neural net, right? Can you change and try to do the AND? Can you try to do the OR? Doing that is basically to change the inputs and the correct results. It's going to be very simple. It's going to work. And how do you know if it's going to work? The error, right? I am curious. Can you just change the inputs? Remember that the inputs are in the main, the first 2 lines? But the first 2 lines are this array with inputs and the array of the correct results. Can you just change those data, run, and you're going to be getting these wonderful results of 0.01 error? Maybe yes, maybe not. I do not know. But my question for you is, okay, after you do it, you check your errors. Number one, it works. Great. Didn't work. Can you fix it? Maybe you can add more iterations. Oh, didn't work, even with more iterations. Can you explain why? Works perfectly. Can you explain why? I don't care if the result is work or not. My question for you to explore is tell me why. It's not working. Can you figure out why? What happened with the and the or that is different from the short? Because the neural net is the same, right? It's going to work or not? And try to explain why. I could be biased to think like something is going to happen, should not be so easy. Or maybe it's easy, is the question one. Clear. I put these 3 items, 3 things for you to think about. With the and, with the or, you can describe both together or different sections for each of those questions. Up to you. Just explain me, possible or not, why? Oh, need to get fixed. How? Next. If you haven't noticed, there are in the main those 2 lines. And I put the name of the variable MSE. First one, second one. I am sure that you compare those 2 lines with an equation that I showed you the previous week, and you notice a difference. If not, you can go and do it for your homework. There is a small difference. Can you tell me? It is different, but at the end it's the same. So it's different, but it's just because the notation is like you are adding 1, but subtracting 1. So at the end it's the same, even though it looks different. Or maybe there are something else. Maybe they are really different. You can tell me. Now, my request for you, if they are the same, you tell me they are the same. But if they are different, there is a significant difference in the notation versus the programming. Then my question to you is, can you change this code to one code that match exactly my equation in the slides? Can you change the code to having the code exactly the equation that we use in the theory? Hopefully the answer is yes, because you are developers. Now, my next question could be, once you change the code to match the equation, is there any difference in the result between the one that match my equation and this one here? Are you telling me that your code is different than the equation that we review in the theory? Small difference. I am asking you for you to check both. If you have a background with the statistics, you're going to notice the difference. You are going to, maybe you already know what happened with this guy. That is fine, you can explain that to me. It's like, yes, I know from a statistic that this version is here, this version is there, and the difference is, etc. I am not assuming that you have that background, but the only thing that I want you to do is to check the difference in the code, to be able to create any of the codes. The one that I gave you already is there, but a code for the other. And moreover, to compare in terms of the result of the software. It is a significant difference, improvement or not, to use this calculation of the error or the one that is going to match the equation that I give you in the theoretical review. You can tell me. Good? Clear. I am talking about those 2 lines. And I am talking about something that those 2 lines are not the same that something that we reviewed before in theory. What exactly? You can review. Oh, my request is that you review. Clear? Question about the question? No? Good. Next. I already asked you this, so just for you to remember, address this in your paper, the array for the bias, have more elements, that the bias that we need. There is a reason. You already helped me with the reason. Hopefully everyone listens. But here's the question. Tell me exactly where and how this bias with more elements is being used and why we are doing that. Tell me if you can. I mean, if you can identify the solution. Can you do the same code in a different way? I mean, keeping this small, to not adding crazy things. But can you change the code to eliminate the extra space in the bias? I am not asking you to do it. I am just asking you to try to do it. Identify where that bias that is bigger is helping us, if it's helping us. Review the source code, understand the source code, be able to modify the source code. That is my question. Clear? Fine? Good. Almost done. Some work. Can you show me the change in the W values? Because remember, everything here is about improving the Ws. Can you use a tool for plotting? Whatever tool you want to use, hopefully something better than Excel, but anything that you can use to plot values. Can you get all the W values? You have an array for the values, but can you capture the different changes in this array for all the values? And then you can take like W0, and I do not want the numbers because there are going to be a lot of numbers and I don't care about them, but can you create some kind of plot and show me for this W0 function of the time, obviously, how this value is changing? I mean, what was the initial value and how this move? Because I show you a plot very nice like this, and it's going to go down. Very happy. Show me the plot for the W's of my example with the XOR. A plot for W0, a plot for W1, a plot for W2, etc. I think the plots are going to help us to understand what happened with those W's. The initial value and the end value and how they change. Just to know it. Nothing special that you're going to look there, but I want you to take a look. Clear. I am not asking you to do a program that do the plotting. I am just asking you to get the values, worst case scenario, print them to the screen or save to a file. I mean, whatever skills you have for programming. And after that, you have the information and go and use a tool that helps you to do the plotting. Again, worst case scenario, open Excel. Well, you can do something better, but depending on your background, do the plotting. A screenshot of the plotting, and you put your plots in your document and move forward. Something that I asked you as previously, put the plots. And can you tell me if there is something important there? Like, can you give me kind of your summary explanation, results or whatever, what you are looking at in the change of the W's? I mean, what do you understand about those changes in the W's? What is happening with those W's? Your own description, your own thoughts. Clear? Okay, this is maybe the longest part, the part that is going to give more time for you. Last one. For the background, for the backward propagation. In the backward propagation, I am in particular pointing out blocks there, the same blocks that I marked with the white box. There are something in the lines 64 to 75, something in the 77 to 88, something in the 90 to 93. And those somethings are, for the first one equation. The equation that is calculating a value that you're going to use later. The second one, three equations. Three equations. Remember, you have three nodes in the layer in the middle. There are three equations there that are calculating something that is going to be important later. And finally, you have in the last line 9 equations. Well, there is no 9 equation. It's one line that is repeated 9 times. And that is the equation for the calculation of the W's, if you remember. Oh, it's 8 equations, sorry. The same for the W's. Can you put, not with the computational representation, not with the arrays in the position, whatever, I or J, can you put in terms of the letters, this input 1, input 2, and all these names, the equations that I am mentioning here? The first one is going to be something about output 0, derivate, input W's, etc. I want you to notice what are those equations, not in terms of the program, because you already have it, they are working. But can you go back from the program to the letters in my picture? Until this point, your homework. Until this point, the understanding that I want you to have about the background propagation. The extra question, either because you have the background or either because you want to research a little bit more. But my last question, looking at this equation, can you explain how those equations were created? Where those equations come from? I give you some hints. I publish for you a link to a paper, one article that I create. At the end of the article, I give you links to explanations of derivatives. Again, if you're familiar with the topic, if you review derivatives in some course before, you're going to read that and it's going to refresh your mind. If that is not the case, don't worry, no problem. This, as I put there, extra questions at the end. What I am curious is how many of you can include at the end of your homework this, because that is going to give me an idea how many people have that background, statistics or math, and that is going to help me to move forward to other topics, either covering that or not covering that. It's just kind of a survey for me. So don't worry if you do not add an answer here, but I am asking you, try to add the answer because it's going to help me to understand your background. Your homework is all the previous one, mandatory. That is what is going to be graded. This one is for me to understand what is happening here. Clear? Questions? Everything good? Yeah. Sorry? I am going to post the slides and I am also going to post the link at the end of the lecture. Don't worry. Yep. But this is what you're going to have there, and you're going to have this link for submission. You're going to have 1 week to work. Clear?
Will you be extra credit for this?
Clear. Questions? Any other thing besides I need to publish this? No? Okay, guys, I'm going to stop here, work in your homework. See you next lecture.